We will now solve problem 6 of the exam given in the fall 2017. Okay, so the first sub-assignment here, solve the set of equation and test solutions. So we need to find out which x's and y's fits this set. There's several ways to do it, but let's say we use the first equation to find something for y. So y equals 8 minus 5x. And we can insert into second equation. So we have 2y plus 10 equals to 3x. And if we insert the expression we have for y, we get an equation including only x's. So let's clean up that a bit. To have 2 times 8 minus 2 times 5, 2 times 5 plus 10 equals to 3x. That would give us 26 minus 10x equals to 3x. So let's take that 10x's to the other side. We get 26 equals to 13x. So we get x equals to 2. Okay, if we insert that into an expression for y, y equals to 8 minus 5x. We get minus 2. So we check our results. So we have x equals to 2 and we have y equals to minus 2. 5x plus y, 5x plus y would then be 5 times 2 plus minus 2, which will be 8. 5x plus y equals to 8, so that was okay. In the second one, we had 2y plus 10. 2y plus 10. 2 times y plus 10, that would be 6. And 3x would be 3 times 2 would also be 6. So the first is okay and the second is okay. So our x has to be 2 and our y has to minus 2, and we have checked our result. The next thing we should do in B is to solve an inequality with an absolute value. So we have 2 minus 5x greater than or equal to 3. That gives us 2 minus 5x has to be greater or equal to 3, or it could be less or equal to minus 3. Because if we, for example, get 2 minus 5x equals to, let's say, minus 10, we take the absolute value of that and we get 10, and that is larger than 3. So in order to make sure, we need our 2 minus 5x to be either larger than 3 or less than minus 3. So this area below is okay, but not in between. So this is okay and this is okay. Okay, we could put it a little bit easier. This is where 2 minus 5x is larger or equal to 3. This is where we have 2 minus 5x is less or equal to 3. And this is also an area where we have a bit larger than 3. And of course they're equal when they're equal to either minus 3 or 3. Okay, so we have two inequalities that we need to solve here. So we have minus 5x larger equals to 1 if we subtract 2 from both sides. And if we subtract 2 from both sides on the other side here, we get minus 5. And then we divide by minus 5 on both sides. And when we divide by something negative or multiply with something negative, we take the less than to a larger or larger to a less. So we turn around the inequality sign. 1. Okay, so let's just make a little check here. If x equals to minus 1/5, we get 2 minus 5 times minus 1/5. The absolute value of that, 2, that would give us plus 1, which would give us 3. So now we got that, that point here where x equals to 3, or 2x minus 5x equals to 3. If x equals to 1, the other one that we calculated, we got 2 minus 5x, which is now 1, which would be 2 minus 5, which would be minus 3. When we take the absolute value of that, we get 3. If we have x larger than 1, for example 2, we get 2 minus 5 times 2, which would be 2 minus 10, which would be minus 7, which would be 7, which is larger or equal to 3. Just like we were asked for. If we take something that is less than minus 1/5, let's say minus 1, 2 minus 5 times minus 1, it was a 2 plus 5, which would be 7, which is also larger or equal to 3. So now this isn't really a check, but we checked first that we get our points where they are equal, and then we took 1 point above and up here and 1 point below and check that we're still okay. We could also check 1 point in between just to make sure that you get something that is less than 3, but still we are pretty sure that we're okay. Okay, in C we get a temperature of a chemical reaction. We have a T, where T is in second. Calculate the time needed for the temperature to double its initial value and test the result. Okay, double its initial value. Initial value. The initial value would be when you have T equals to 0. When we take 3 to the 0th, we get 1. So the initial value would be 10. So what we are asked for is calculate the time needed for temperature to double its initial value. So we want to solve for t, small t, when the large T is equal to 2 times the initial value, 20. So 20 equals to 10 times 3 to the 0.02 T. Okay, we could divide by 10 on both sides. And now we need to get that T. The way we do that is that we take either the natural logarithm or the logarithm with 10 as a base. You could choose either. So if we take the logarithm like this, logarithm of 2, you could put 0.02t in front, like this, and you then have a t, and you have some factors here that you could divide by. Here. Now we kept the logarithm 2 instead of calculating it and putting in decimals, because I want my answer to be as accurate as possible. So when I put that into my calculator, I get 31.5, and I would get it even though I used the natural logarithm ln. And I test the solution by figuring out what the large t would be if the small one is 31.5. 10 times 3, 0.02. Then I insert my t, and I get something that is approximately 20, so it is okay. And now my question is in words, so I need to answer with words or text. The time needed for the temperature to double its initial value is 31.5 seconds. And that was it. Okay, D. Now I'm simply asked to find the first derivative. The first derivative, I need to use the product rule. So I use the product rule. The reason why I need to do that is I have something and I have times something else, and both of them have x's in it. So if I choose u equals to 4x to the third and v equals to 2x minus 1, I can find a derivative. 4 times 3x squared, and the v here would be, the sinus would be a cosinus, and this is the I need to use the chain rule for, so I need to find the derivative of that, and that is 2. So the derivative would be y, the derivative u times v plus u times v derivative of v. Yeah. So I insert whatever I have, 12x squared, that was the derivative u, times the v, plus the u, times the v. I could clean up a little bit, but not much. 12x squared sinus 2x minus 1. 2 multiplied by 4 would be 8x third cosinus 2x minus 1. And that's it. I have another one I also need to find the derivative of. Here I have to use the chain rule. So I get 4 multiplied by 6x to the third minus 3 to the third multiplied with the derivative of what's inside the parentheses. So that would be 6 times 3x squared minus 1. So I get 4, 6x to the third minus x, 18x squared minus 1, and that's it. If you did not understand exactly that, you could put f of x equals to a set fourth, and then you would get the derivative of that equals to 4 set to the third times set, the derivative set, where our set would now be what's inside the parentheses. I don't know if you find that easier, but yeah, either is okay. And now you have an indefinite integral. The reason why you see it's indefinite is that you don't have any borders or limits. It is also quite awful, if I can put it like that, because you have something inside the parentheses here, and you have some x's outside. You could use, the UV thing, but if I do that, I need to find the derivative of the u, and then I get a sign, which doesn't really help me. But I could also use the substitution thing. So let's see if that works. If we put this equals to a y, or u, I see that my u derivative would be 3x squared. And that x squared thing is what we have here. So I find except that we have a factor wrong, I have the derivative of what's inside the parentheses here outside. So maybe it works with substitution. Let's try. We have u equals to x third minus 2, which will give me the derivative of u equals to 3x squared. You could also put that as the u dx, 3x squared, which will be, if I multiply with dx on both sides, du equals to 3x squared dx, or du over 3x squared equals to dx. Anyway, if we then look at the integral, we will now have what's inside the parentheses. We exchange with a u, And the x we exchange with the u over 3x squared. Okay, now we need to concentrate. I have a 5 here and a 3. And those two I can put in front. Now I have x squared divided by x squared, so they basically cancel each other. And then I have cosine of u du. And that is pretty neat, actually. So I have 5/3, and then when I integrate cosine, I get sine. And since it's indefinite, I need to have my constant also. The final thing I have to do is to put back my x's. And that's it. That's it. And then we have the g. Okay. Again, I need to look at this and see what I can use. Here inside the parentheses, I have a u, if I use substitution. The derivative of my u is now 2. And outside I get something with an x, not with only constants. So in this case, I cannot use substitution. But what about integration by parts? So if I put my y equals to 6x and my v derivative equal to ln 2x, I get into trouble because I cannot integrate that easily. So therefore, I do it the other way around. I put u equal to ln 2 of x, and that I can easily find the derivative of, like that, using my formula sheet. And I can integrate 6x to be 3x squared. So my integration by parts would then be something like this. I just write the formula first. That's it. Okay, so we have chosen now u equals to ln 2x and my v derivative equal to 6x. So what I have here is what I have here. So 6x ln 2x dx. And then I have u times v ln 2x times v, which is 3x squared, minus the derivative of u, x times v. Here we have it. Okay, I want to put the 3x squared in front of the ln. It just looks better. In the integral, we now have 3, and we have x squared divided by x. So we get x. And that's fairly simple to integrate. 3x squared ln 2x minus 3 half x squared, and we need to remember our constant. And that's it. Okay.